everybody. We're going to start with some chapter 7. It looks like Mewbot just woke up. Hey, Mewbot. Is he still on the soundboard?
I am Mewbot.
Thank you, Mewbot. Let's do this. We have a problem with copying in the data. So, Lida, it looks like maybe you're copying without column names. I'm going to pull up the data right here. So, give me a mopin. I don't even know what I'm trying to say. Give me a moment right here. I'm going to pull up the data and we'll take a look. Let's go get the burger question right here. Calories and burger question. So we will replicate the issue. So I've got the data open right now. Let's go take a look at this. How's everyone doing today? Can everyone hear and see me? Sometimes I'm worried. I'm like, oh no, am I streaming? My background has stopped. Now it's started again. Hey, Kayla, good to see you here. So Mewbot should be talking to everybody. Let's hop over to the main screen right here. And let's go find that calorie and burger question. And Kayla, you probably saw I made a small update to the assignment. We did, correct it during office hours. I'm doing great. And I just felt because the medians thing was having issues, and I was like, eh. So if you look at the QQ plots for the question, have you looked at the new one yet? I don't think it's so bad. Like you look at the QQ plot and you're like, oh, looks an interesting QQ plot. Which is something we should definitely know for tool 1 also, so we can look at that. Hey, good to see you here, Maggie. Let's go ahead and copy this to a clipboard. We're going to hit copy, 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 copy. You only got to copy it one time. And then we're going to go over here to a new file, new data table. Now, this is the key. Go to a new data table. So it's such a small change, Caleb. We can take a look at it here after this one if you like. So we're going to go over here to a new data table. And this is the key. Whenever you go here, you need to go to edit and paste with column names. So Lida, is it Lida? So if I'm saying it correctly. Make sure to paste with column names. When you paste with column names, it'll come in here as blue, which will mean it's numeric or quantitative. And then if you don't paste with column names, it'll look like this. So this is the wrong way right here. If this happens, do not try to fix it. Start over. Why not today? I'll show you how you'd actually have to fix it. So this is how I fix it, and this is how quickly it can be done. I just go here and I paste with column names using the shortcut. Ooh, and it didn't all paste. Oh, because well, apparently I didn't have everything copied, so I need to paste with column names right there. And so there we go. And now we've done it. Lydia. Okay, good. Lydia. Sorry, I don't know how to pronounce any names. So I get awards with brain on it, and I'm like, sure, whatever. If you had to fix this, it would not be fun to fix. Like, so tell me if you're able to, like, this is how to fix it without just redoing it. Like, this is the time it would take to fix, like, to go through here and do the steps of fixing it. You have to go through here and do all of this. So there's one column fixed. It's now blue. And here's the other column fixed. So, oh, no worries. This is a big question. We talked about this a lot yesterday, but don't worry. This is like something that if it happens, you just can't do the data. And now it's blue. It's fixed from red. But the best way to do this is when you go to File, New Data Table. You go right here and you go to Edit, Paste with Column Names. I know the shortcut for it. It's Command Shift V instead of Command V. So now it pastes with column names versus when you just paste. So there's pasting, and then there's pasting with column names. Oh, it didn't put the column names in. Oh, because I didn't copy the column names. Okay, so now when I paste, it will paste. I don't have the column names anymore. Well, that's weird. That won't happen when you do it. I can go back to the problem. And here on the problem. So is this making sense right here? When you copy, it's copying the column names. So when you're inside of jump right here and you're in a new data table, you have to then paste with column names. That's key. If you don't paste with column names, it'll put them right there. So now I have the column names again in the paste. It didn't have the column names in the paste. So hopefully that's all making sense. I'm just going to say column names like 50 times. But the big way on the screen all the way over there is the right way, and this is the wrong way. Very common error. On the YouTube page, where do we find the lectures? I can only find the recorded office hours and the coots, but not the lectures. Bailey, you're in our class, right? I think you're in like one of our 2 sections. So I don't put the links on here. You're welcome. Yeah, awesome. Well, have fun in class, and glad we could help out there. Don't worry. That's a big question that arises, like, wait a minute. this isn't pasting in properly. So let's see here. So Bailey, let's check out. Which section are you in, Bailey? And I will show how to find which class. You are in the asynchronous. Awesome. So with the asynchronous, go to right here and then go to live at 4:30 on Monday, Wednesday, Friday, and live at 1:10 on Tuesday, Thursday. And when you go to this, and I'm not going to go through these links right now because they show the playlist, but you can click this right here. So if you go on Canvas, you will see these links, and these bring us to the unlisted playlists. So the playlists for the classes are unlisted. Does that make sense, Bailey? So YouTube has an option to make a video unlisted where someone has to have the link to get to it. So that way it slightly protects our classes. That way, if anyone gets to the class, they've had access to the link somehow. And so I don't put the links out there for the playlist, but they're available via these links on Canvas. So anyone on Canvas would be able to get to it. Like if you're on Canvas, you can find the links to the playlist. Does that make sense? So go ahead and click these, and you should see a full list for each class. Yes, good. And great question, Bailey. Thank you for asking that. Because like I keep saying with oh my gosh, Lydia, it's not in the comment. Like Lydia was asking, all these questions, a lot of people are wondering, and Bailey, I'm sure a lot of people were wondering, wait, where are the videos? I've had people even in the other classes asking, wait, where are the videos? And their links are very similar. Theirs just says watch live because they only have one time. So I gave asynchronous access to both classes, but in the other classes, and long story, can you see? You can say, yep. Let me take a look at that. And there's the watch class live for any other class. So other classes just have the watch class live. Bailey, we're going to take. No, I've got a rule. Bailey, join one of the classes. I've got a rule that I don't mod anyone during office hours because someone could come in here and like be like, "Hey, I'm in the class, I swear." But come to any of the classes and be like, "Hey, Brian, mod me," and I'll make you a mod. Like Sarah's a mod right here. So I'm gonna go take a look at Sarah's. I think. Let me check, make sure I'm not displaying this on the main screen. Yep, it's on the side screen. Okay, I got zoom on. Let me take that off. Okay, let me take a look. Here we go. Thank you so much, Sarah, for sending this. Let's take a look. Can you see if the visualization, if 7 is correct for the second part? That, does it say it needs account access? I think you're just doing the conference roll, right? Looks like you did it correctly. You're doing anticipated starting salary, and you made is 94.5% conference roll. And I see Lydia's on there saying, and yeah, I am 94.5% confident the true mean starting salary for UT students is contained in the interval and then blank to blank. So that's what you'll write right there to interpret it, and that should have all the key parts. Great job, Sarah. Have you done stuff like conference rolls before? Because you're 100% on track where you need to be with this, and that's how you make the output. It's a univariate analysis of data, just analyzing a singular mean, and that's got it. Excellent work. Thank you, everyone. Like, I'm really glad. I'm so glad we have Discord because you can just send me the message, and then I just see it right away. Discord is. For those like Sarah, would you say to students using Discord like to communicate, at least in this class, is pretty easy? Because I'm trying to get as many people to like message on Discord. So it's like, oh, if you use Discord, you can just be like, hey Brian, take a look at this. Boom, Discord. Okay, let me go to the Discord manager. Got it. It's really easy, instantaneous communication here. I'm gonna go and I'm gonna react to it. So that way we know. That way when I go and look at this again, I'll be like, yes, it's good. It's usually that's my like go to reaction. Like, good job. So to me, I really like Discord, and I don't know. He said, it's definitely easier and faster. Yeah. I said, I'd hate to be like everyone has to use Discord because I know there's gonna be some people who are like, I'm not a fan of Discord. I don't know how to use it, which is all right. I mean, so I would hate to be like, I don't do email. I'll only do Discord. And they're like, I don't do that Discord thing, Brian. So it's kind of an optional thing, but definitely one thing about Discord for anyone watching is whenever we have to have like a back and forth where I have to oh yeah, Bill Bailey, join on it, and yeah, and we'll do the SAT question. You got it, Ben. So and then where is it? Kayla, if you're wondering, we could hop over to some 320. Feel free to ask anything, Kayla, on 320, because I'm sure some 320 students are gonna be like, Kayla, ask the questions, because they're gonna be like, oh, I wish. Hey, but 320, if you show up and you ask questions, you get them answered. So, but I think this week's summit's a bit easier. But Bailey, if you ever have any questions, let me know. But yeah, and if you're on Discord and you're like, hey, that's me in the chat, I could probably mod someone. Like if you're like, hey, that's me, and because just want to make sure I'm modding mods. Anyways, let's go look at that SAT question. Oh my gosh, what's going on there? Okay, let's go look at. Are you talking about? Tell me if this is the right one, Ben. When we get to it, I'm pretty sure. Is it this one? There's two SAT questions. Is this one you're talking about, Ben, right here? Is it the math and verbal score one? Is it the math and verbal score question, or is it the other one? So math and verbal, or is it this one? Wow, I found it. Is it? It doesn't have a scatter plot. Then it's this one right here. There's two. Not that I've done these a few times. Okay. So I'm assuming it's this one right here. Yep, SAT and GPA. You got it. So the SAT and GPA one wants us to do the regression line. Can you write right now the regression equation format as though this is, we won't have to use a regression calculator on the exam. We won't have to solve. So what's really good is the regression calculator that I made basically takes away any of the work you wouldn't have to, like, it makes it so anything you do would be like it'd be on the exam. Simon 4, but I'm just curious about your level of knowledge on using R with matrices. A little bit. That's a good question. Let me just comment on that really briefly, and then we'll hop back to this question. Like, one thing I like is you can get the determinant of matrices. So maybe, Kayla, you're looking at the mathematical side of R, but that's a bunch of cool things you can do. You know, if you make a matrix right here, you know, and so you put in your data first, and then you put in the dimensionality of it. So you could put in something like this, and then you put in the dimensions of it, and that made a 2x2 matrix. And now you can just easily get the determinant. The determinant's going to be 4. Oh, am I forgetting? It's going to be 1. We think down, over. So it's going to be 1, I think. The determinant's going to be 1. So determinant of x is 1. Yeah, I still know how to get the determinant of a 2x2 matrix. So, because you go down and then you minus going over. 3x3s, I'm not going to have fun doing 3x3 matrices. You know, linear independence, linear dependence. Yeah, this is a, you know, we can make a linearly dependent matrix. So let's go right here. Let's go 4. Let's go 2. Let's go 2. Let's go 1. This should be linearly dependent now. Yeah, it's a linearly dependent because this row right here is a linear combination of this row. So that's, yeah, that's 4 and that's 4. So it's 0. And there we go. So that's good stuff right there. And so we'll hop back here. But no, there's some cool stuff you can do. I mean, that is the absolute basics of matrices right there at Kayla. But ask some more questions, email me some, and maybe I'll get better at my mathematics. I'm doing like the first week of linear algebra right now. That's week 1 linear algebra right there. Yay, I still remember some linear algebra. Here we go. Let's start this question up. Let's do it and ask all the questions you have. I wish I was better at mathematics, Kayla. I was good at mathematics at one time, and then I got to college and found out they took away my numbers. They said, here's your numbers, and I'm taking all your numbers away. I'm a numerical analysis, and would you rather use R than MATLAB? Oh, that's awesome. Well, yeah. And if you can share with me what you're doing, let me know, because I'd be happy to look into it. Awesome stuff right there. And is Ben also? Ben also, are you in that? That's awesome. That's, hey, I like using R, and I wish we could. I could make it so R could do this stuff, but we'd have to program in the equations. It wouldn't be that hard just to write the equations in. So here we are. So Ben was asking, he said, my thing is, how do we know which one is Y and which one is X? So, well, right here, look at this equation, Ben. How do we know which one is Y and which one is X? So when you look at this, try writing right now for practice. Try writing the basic form of the equation. Try writing the basic form of the equation without any variable names in it. So try writing the very basic form of the equation where we predict, and then we have something here, and then something here. So write out the basic form, which is something we should know. Write out the basic form. GPA is Y hat, exactly. And so the formula for the equation is going to be, and great job, Ben. It's going to be Y hat. Oh my God, that's Y bar. No! Y hat equals B0, which is the intercept, plus B1 X. And so B0 is this value down here. B0 is this, and B1 is the 1 unit change. And for 320, so for Kayla, well, you'll hear this very soon. When we do multiple regression, we'll add on to this for like our multiple. Sure, why not this color? So Kayla, we've just put some extension here on multiple regression to take a look at what we'll be seeing in our class to kind of bridge the gap between 201 and 320. So think about why we call it B1. Why would we call it B1? Because B1 is the coefficient for the what? So B1 is the coefficient for the what? Just think about why would it be called B1? Because B1 is the coefficient for the what? And why would this be called B2? Because B2 is the coefficient for the what? So just kind of think like, why would we call this B1? Because it's the coefficient for the what. Why would we call this B2? Because it's the coefficient for the what. And why is this called then B0? It's because when there's no what's in the model. So hopefully you should be like filling in the blanks like, oh, it's B1 because it's the coefficient for the first X. Does that make sense? And this is B2 because it's the coefficient for the second. It's like the weight. It's like how much that pulls on the model, like how much value it has when you change units of this X right here, how much it'll change the units of the Y. The B's are the weights on the model. They're the coefficients. And yeah, the higher the coefficient, the more impact changing X will have on Y, the more influential. Not really statistically significant. That would lead, we'd have to talk about uncertainties in the estimates, which we could. But right there, Ben and Kayla practicing some regression, and we're going to go very in detail on regression for 320. 201 gets kind of an idea of it, and then 320, it's the main meat of the course. It's in the middle, sandwiched between some associations and some, well, no, we do logistic, and then we do model building. Okay, so the big thing now, Ben, we'll be using the regression solver. I added to mine yesterday. I should upload this new one. Oh, and we have, oh, cool. Okay, so if we copy paste like we did yesterday, we did this one yesterday, but we're going to try to, let's see if we can copy paste it exactly the way we wrote it. Oh, that's great right there. The canvas contours are closed because it's part of, has to, could you, are they, yeah, email me about that, Bailey. Make sure they're open. Yeah, email me on that, Bailey, and I will open them back up. Sorry about that. Email me, Bailey, and I will open them back up. It's really, I'm wondering, it's just weird how they work, because I want it to be like you have to do them by a certain date or you don't get credit. And I might be settling for, well, you can still get credit if, yeah. Like if you do them, because my what I'd really hate is someone to be like, just, it's not conducive to like do them, like what you're doing is the right thing. Like practicing them again is exactly what I want people to do. But my fear, and this is because this is the first time I've actually made these modules with like due dates and stuff. My fear would be, and you're not doing this, my fear would be someone would be like, oh, I don't have to do them till the night before the test. Because like, but you know, I mean, I'd rather give the students like yourself the opportunity to redo them and deal with the fact that some students might be like, oh, well, it looks like I can just wait the night before the test. I just yeah. So we won't tell anyone that maybe you could undo like a bad grade. Don't tell anyone. And if they undo a bad grade, that's not the end of the world. If they do good on the test, that's great. But just knowing what I know, it's not, does this all make sense? That's the hard part about being a teacher, is you have to do the psychology of it, which that's what my undergraduate is in. You have to do the psychology of like, how do you help people learn? Like psychologically speaking, what is the best due date to have assignments on? You have to think about all these things. And we'll go purple today. Really? Purple? Ooh, it's crashing, everyone. We will solve the problem, Ben. Maybe. Oh, okay, crashing over. It wants us to use green. This is a sign right here. We have to use green or purple. Okay, I should have taken that as a sign. Okay, we got purple. Let's do this. This is weird. I don't like this. We're currently crashing. We're back to blue. Maybe I should, okay. We're just gonna not change the color of the pen today. You know that? We're not gonna, okay, it's saying, I gave you a shot at a different color, but no. So we're predicting SAT score, I believe. Let's go over here to look at what we're predicting. We're predicting GPA. I was wrong. We're predicting someone's GPA. Yeah, there. You know what? And the problem with that, there, Kayla, I should do that via Canvas. There's the small issue with that is if someone redoes it, it'll actually. So I've experienced that. So if someone redoes it, it'll actually take off their grade for the days late. So no, Kayla, that's a really good suggestion. And you can have it, Canvas will automatically deduct a certain amount of points. And with these things that you can redo, when you redo it, then Canvas updates the grade. Maybe there's a way you could take highest. Ooh, Kayla, you might have just solved it. Because maybe I think there's a setting where it says take highest grade. So if someone redoes it and gets a lower grade, it won't redo the grade because these are like auto-graded. But Kayla, let's throw some points out here. 50 points. Because you might have those two things together with something you're suggesting is something I know that might actually solve the issue. And so, Kayla, you might have just fixed it for everybody. Like it right there. That could be it. We are predicting somebody's GPA. So if we have a mean of SAT score, the mean of SAT score is going to be the mean of X. Oh, no, 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 no. It's going to be X bar. Woo, we got X bar right there. And the standard deviation is going to be S sub X. The standard deviation, the mean of GPA is going to be the Y bar, because that's the mean of the Y variable. This right here is going to be S sub Y. I really mean it. Like, students help me figure stuff out because there's a lot to figure out. There's a lot of like, just, like, how do we get this to work? How do we get this to work? And how do we make this system best for everybody? And that's what we do. So we have here, we're going to need to erase our data. Let's erase the data. This is the Regression Solver Pro. It's just an applet I made, and I made another part to it yesterday just because why not? If you're looking for where this applet is at, go over here to modules if you're in our section. If you're not, email me. Yeah, we can do some 320 next. You bet, Seth. Ask any 320 question you have. We can do it. Here's where the Regression Solver Pro is at. It can be used for the data, or it can be used for the coefficients, which we're trying to find right now via the summary statistics. So we're going to put in the, that's the correlation right there. The correlation is 0.045 because R is correlation. Next, it asks for the standard deviation of Y. Where's standard deviation of Y? That's 0.51. You have to put everything in correctly. That's the deal with it. Standard deviation of X is that. The mean of X, where's mean of X? Mean of X is 1229. And the mean of Y is 2.61. Okay, so we've done it. We've done it. It now gave us the intercept, and it now gave us the slope. Stuck on task 3, you bet. Let's go look at task 3 after this. So, good, not crashing. So let's go grab these numbers, put them in over here, drag, drop. 5, 1, 2, 3, 4, 5. That's going to round up to a 4. I wish it just let you put in the remaining decimals. And that's 5 decimal place accurate already. Okay. Got it. Oh, it dropped more decimals in. We will look at that task right after this. And so what is the y-intercept? It's when x is equal to 0. Remember right here, we're going to set x equal to 0. So it's when someone's SAT score is equal to 0. Explain the y-intercept. Good. The y-intercept represents the prediction of an SAT score. Nope. Prediction of a GPA, because we're predicting GPA when someone makes a 0 on the SAT. This is what we call an illogical intercept, 320. Listen up, because when you plug in 0, hey, what's up, Carson? Carson, you took 320, right? So Carson, I was trying to get someone on to talk about 320 yesterday. You took 201 and 320. Would you say 320 gets easier, or like the start of it's pretty tough? Like, I'll let you speak for yourself, Carson, but I always like to say to students, it's tough at the start and gets easier as the course goes on. Like, you hit this bump in material and the car's just like swerving, and then you kind of grab a hold of the wheel and center it out, and it gets a little bit easier. Because I think one of the assignments we just did, I did indeed. And feel free, your comments, Carson. So good to see you, Carson. Carson with his Rugrats hoodie. I'll never forget Carson. 1 year ago, sitting on the right side of Stats 101. Carson, and why can't I think who's next to you? I can see him. I can see him. He wore a necklace, like cross on it. Like, I can see him. I just can't think of his name. And you're like, come on, Brian, how can you not think of my name? You know exactly what I'm talking about, Carson. Carson's going to say, he's from Texas too. First 2 assignments were tough, but after that was easy. Yep. And I changed it up a little bit this semester, but they just hit a tough assignment, and I think it's going to level out. Yeah. Like we changed up a little bit this semester. Walker, of course, Walker. Yeah. From Texas. Swing by office hours, blondish hair, right? Like Walker, tell Walker I say hey. I was like, I can see things. I just can't think of names sometimes. Oh man, I miss you guys. I miss seeing people in office hours. You guys were the last group I got to see in office hours. I miss it. So interpret the slope. My hair just keeps getting longer, Carson. This is getting pretty crazy. Interpret the slope of the regression line. The slope represents for each 1 unit increase for each additional point we have in someone's score. There we go. So there we go. Predict the GPA of a freshman who had a 1400. So one way you could do this is you could just plug 1400 in here for score. Let's do that. Let's just go here to score, plug 1400. We're going to times that by 0.00191. And we're going to add that to 0.25954. That's awesome, Carson. Hey, it's still crazy times, so we're just gonna, why get a haircut? What's the point? Just let your hair keep going. Mubot does a lot more talking now too, Carson. I made some updates so that he will say things like that right there. Don't worry, you don't gotta tag me. It's just like I'd hate for people to think I'm like saying that right now. Mubot just talks. He does this thing. Based upon these statistics, how do you think SAT scores would be in predicting? Oh, you were there last semester when I made Mubot, yeah. In predicting academic success during the first semester of freshman year in college. Oh, this is the one we got wrong yesterday. Not getting it wrong today. But did we get this one wrong? Oh, it's because of this right here. Yes, there's a lot of quotes now. You know what's going on with quotes. It's going to be SAT scores are not very effective because that's pretty low. Keep checking more quotes. We're up to like quote 57, I think we got yesterday. This was during Stats 1, we got quote 57. You'd have been there for Stats 1 for it to make sense. I think it was quote 57. Mimot's slow sometimes these days. He doesn't talk quickly anymore. As a student, would you rather have a positive or negative? We were talking about predicting somebody's test score when they are 0 years old. Would you rather have a positive or negative residual? Positive residual is going to be above the line. Negative residual is going to be below the line. We're talking about where someone would be. And I might have a graphic up for that. I might quickly just kind of glance over these to see. I can draw it out in a second too. But we probably have, this is all 320 yesterday. And where is our, this works. So this is the observation right here. And if the observation is above the mean, that's a positive residual. And if the observation is below the mean, it'd be a negative residual. So with this individual right here, their actual score, which is where they are at, would be above where they're predicted. So all these Y hats, oh, thank you so much, Carson. I appreciate that. All these Y hats right here. Does that make sense what Y hat is, Ben, everyone? Y hat is the prediction. So when you're making predictions right here, Y hat equals B0 plus B1X. The Y hats are all the predictions, and the Y's are the actuals. So if you have a test score, you'd want to have a positive residual because that means your what is to your what to your prediction. Yeah, exactly. And it's context too. Context always matters when we do statistics. So it makes sense that if you have a positive residual, what would that mean? Because right now we're predicting somebody's GPA. So the GPA is the Y variable. So we're predicting GPA. And Lauren, good to see you here. Feel free to ask some questions. And we're doing SAT. So good seeing you, Carson. Thank you for swinging by. GPA is higher. We're going to throw some 20 points out for Carson Beer. Kind of. So what is Y hat? Like you're pretty much right on track with that answer. Anytime, man. Anytime, swing by. So what does it mean? You're right. So you're saying GPA is higher because it's, well, so the Y hat would be the what GPA for somebody. So the Y hat, like this is this person's Y hat. Like that point right there, and we'll do it in the color of the line. This point right here is that person's predicted GPA, exactly. And then the Y is their actual GPA. So you could see the residual right here. We'll do the residual in red. So what would the residual be if the numbers are something like 3.1, and then up here we have something like, what would this person's residual be? And then kind of talk about it in context. So what would this person's residual be right here? So understanding residual, what would that person's residual be? It'd be 0.5. And then what does that mean? And great job, Lauren, right there. Yep, we are higher than we were predicted to be. So a positive residual means the actual, and to do the residual formula, it is the actual minus the predicted. I don't have that, so that's the residual. That's supposed to be red. Residual equals actual minus predicted. So residual equals actual minus predicted. So it's just the distance these points are away right here. It's just their GPA. That's Lauren. We're throwing another 20 points. You're exactly right. That's what the residual means. Their GPA is 5 points higher than the predicted GPA. That's exactly the interpretation we'd want right there. These formulas can look really complicated, like E minus Y, E equals Y minus Y hat, but it's just the actual minus the predicted. Residual equals actual minus predicted. Just remember residual, that's what E stands for, equals their actual minus their predicted. I didn't have the green up yet. I remember residual wrap, residual equals actual minus predicted. They actually made a 3.6. That's their actual score. They were predicted to make a 3.1. Their residual thus is 0.5. And so you'd much rather have a positive residual. Long answer there. And so their GPA is higher than predicted. Did we do everything right? Woo, I got scared right there. I think there was, we're going to hop over to 320, but 201, keep asking questions. 201, it's your time to ask questions. I think, when's my next class? One of these days I'm going to be doing office hours and everyone's like, Brian, why aren't you teaching class? I'll be like, oh, wait, class time? Let's hop over here to assignment 4 update. Let me download it. Okay, so we updated the assignment last night. Very important thing for 320. I'm working on chapter 7 homework now, and I'm starting with the residual on the standardized test score one. Oh, yeah, here, we'll do that one next, Bailey. How does that sound? In about 10 minutes, we'll do that one. We're going to focus on 320 for a second, but you got it, Bailey. That will be the next question we do. We're going to jump over to 320, and then we'll do Bailey's question next. I'm going out on a limb. No, I can't do it. Bailey, join. Oh, sounds like people just really want to be mods on this channel, right? Because we give all the shout outs. We shout out, today let's shout out, who should we shout out today? There's only a small change. I'll show you the small change right here. It's a very, very, very small change. The small change, which you'll see, I wrote an update on it. So here's the update assignment, and as long as it was in the announcement last night, if you saw the announcement, like 1:30 or maybe 2 a.m. your guys' time. Why sleep? No sleep. The only change is right here. This is the only change. It's going to go away. So this is the only change right here, Seth. Does that make sense? I only changed the variable right here, and this makes it so it works no matter what. And I was testing it out and doing some analysis with it and everything. Does it make sense that this is the variable and it should work with everything? Shouldn't crash, shouldn't have issues. Code is fun, but I made a solution around the other way, and I was like, it's going to make it more confusing. So I just changed the variable, and then I'll inform the graders if someone uses the other variable, it is acceptable, because we did put out a version of the assignment with the other variable. So it is acceptable to do the other variable, but I would not. I would do the updated variable. Does that all make sense, Seth? That the only thing updated is the variable name, and the announcement has in it what variable we've changed it to? It does. All correlations output. We'll be doing all correlations today. Awesome. Yep, and it's just that one thing. If you just update that one variable, that's all it is. So you're not changing massive things, and you can just update the variable. It should be a pretty quick fix to change the variable, and the analysis, just depending on what you choose, should be kind of interesting. So with this right here, we're going to do the all correlations. So correlation is chapter 6 for 201, and in 201, there's a really cool, let me look at one thing real quick right here. So I'm okay if you add this into your analysis, and I think I can find it in just a second. Ooh, yes, I found it. Okay. Yes, okay, I like this. Okay, here's something really cool. Okay. Let's go here, and you could add this in, but you got to be careful. We're going beyond the class for a second. I always like going beyond what we're doing. Do I have performance analytics still? I do have it. So, Seth, how would you get performance analytics if you don't have it? If you don't have performance analytics, how would you get it? Because this is a pretty cool function that they have right here, the performance analytics function. This is not, we won't do this in class, but I do like showing extra things. And so the performance analytics is a library, and you can get it with install packages. This is above and beyond, but you could actually do some kind of graphics with this, which is kind of neat. So what this does is it's going to make this chart right over here, which is exactly Kayla. Yep. And check this out. This is a pretty neat graphic, which gives you all the univariate analysis of the variables via histograms, gives you all the scatter plots, and then gives you the correlation. And then via the strength, the bigger the number is, the higher the strength. So you can see the strongest right here, and the variable names. Ooh, that's my only complaint, is the variable names. Oh no, the variable names are here. This is DISP, whichever that is for cars with weight. And so you can see the two right here have the strongest. And then it also even plots the form of the relationship right here, where you can see either they're linear or some of them are not so linear. That's a very weak nonlinear one. So you get the form of the relationship. That's a nonlinear also. So between weight and HP, and up here you can see, oh, is that real? Oh, no, it's this one's 0.66. Oh, and then what do the stars represent? What do you think? And that one's so tiny. What do you think the stars represent? This is graphical overload. Like you wouldn't usually present someone this graphic. What do you think the stars represent? That one of these ones that are bigger and the smaller ones don't have as many stars. What do you think the stars represent? Because this is like graphical overload, and I love it. You can see the form of the relationship. You can see the strength of the relationship. You can see the direction of the relationship. You can see the univariate variable. You can see a really bad number line. Who knows? 20 points. What do you think the stars represent on this graphic? What do you think the stars is trying to tell us? The ones that are stronger, level of statistical significance, exactly. What I think they're doing is 1 star means 0.05, 2 stars means 0.01, and 3 stars means below 0.001. So it's going to be statistical significance, and which kind of means they're stronger, but I'm pretty sure they're denoting statistical significance with this. And I wish it said in the output. It probably says, if we go to chart, and you don't have to use this one, but the reason I would show this, does it say anything about the stars? It really should in the documentation talk about the stars. The reason I would use this is it's way better than a correlation matrix. We talk about correlation matrices in 201. Here's a classic correlation matrix. So you should know this for 201 and 320. Does everyone understand to find what is the strongest correlation in this correlation matrix? This applies to 201 and 320. What is the strongest correlation in this correlation matrix between what and what? What is the strongest correlation in this correlation matrix? This is the same sort of thing you just looked at a moment ago, but we don't get the cool like univariate analysis across here. You don't get to see the form, you just see the values. So it's the same sort of analysis as this right here. Same sort of thing going on. And so what would be the strongest? And I'm going to take a look and see if I can figure it. I think I see it. It's really close between two of them. What is the strongest correlation right here? What is the strongest correlation? And then I'll show why we don't use this. So I'm showing this because you should know what a correlation matrix is. They're very common. We should know everything that everyone uses. And then we're going to do like advanced things. Because it's like, well, this is good, but then if you're doing really big data analytics, you're not going to be able to use it. And you'll see why. No one knows what the strongest is? No, there's a 201, 320 question. What's the strongest correlation right here? This questions like this, face symmetry and fitness score. Let's take a look. Face symmetry and fitness score. Oh, you are correct. Wait. Oh, wait. That is, there are stronger ones. Face symmetry and fitness score, there are stronger ones. There's a, does everyone see this right here? This will be the strongest. Tell me if I'm wrong, but this is the strongest because it's closest to 1 or -1. If that was negative, it would still be strongest. Does that make sense, Kayla? That is the strongest correlation right here between all these. Yeah, score is, I think it's attractiveness score because it's the attract matrix one here. Oh, you were saying face symmetry. Oh, this is like, that's its own thing. Score is, I think, the attraction score. We can take a look at this too. It's attract M data set. The answer for what exactly that is. The score is a numeric vector giving the average attractiveness score compiled after 60 student ratings. Oh, okay, yeah. No, that a good question right there. And so the score column right there is somebody's compiled score, and so that's like an aggregate score after people rated them, an average rating score. Does that make sense? So, hey, what matters context? Kayla, 20 points right there. Yeah, don't worry. Knowing the data is going to really help and understand what's going on with this. And so here's the thing, we talked about how cool this chart graphic is, but watch this. That's what I thought. It got mad at me there. Let's do, it got mad and said no to that, and I think I know why. Yes. Well, here's the correlation matrix. Okay, Kayla. You know what we could do? Let's go to with this knit. Let's go right here. Let's see if this knits. Might hit an error. Oh, I don't think I have a student ID in here. Let's put in a student ID. Knit to RMD, knit to HTML. Don't crash. It didn't crash. Kayla, tell me what is the strongest correlation in here? So Kayla, what is the strongest? This is another correlation matrix. And if you notice, we're getting NAs here because, oh, I wonder why. This whole thing is just insanity. So what is the strongest correlation in this? And should you turn this in your assignment? Would this be good analytics to search through this and find the strongest correlation? The answer is obviously no. This is horrible. Like, no one should turn this in. But this is a correlation matrix right here. And this is why you kind of hit the brink of what correlation matrices can do, because this is too much output. This is insanity. So what could we do that'd be exactly excessive output? And they're going to stop grading your assignment. That's really bad. And so let's go look at what we have right here in the notes. We have a correlation, all correlations. So what does all correlations do? All correlations literally gets you all the correlations between every variable in a pairwise format. It does like variable 1, variable 2, variable 1, variable 2, gives you the correlation and also gives you the significance. But there's additional arguments where you can specify your interest. And what is interest going to do? It's only going to look at the correlation for that one variable. It sometimes is in the variable 2 spot, but it will be included here no matter what. So if you say you're interested in score, it'll only make sure that it analyzes score. But what's even better is we can go here and we can organize the data so we can say sorted by a certain variable. So you always give it a data frame you're going to analyze. You can tell it the variable you want to analyze with interest, and you can tell it sorted, like how you're going to sort the p-values or the correlation strength. We're not going to use strength. We're going to use magnitude for ours. So let's go ahead and take a look at this right here. Sure, I'll fix the notes later. Let's go down and look at some correlations. Okay. So when we do all correlations, I'm just going to use survey 11 for the moment. What do we get? Literally, it's just going to show me what right now? What is all correlations showing me right now? What did it just print to the screen? It's way better output than the other one. If you look at this compared to the other one, it's going to look way better. What is all correlations showing me? It's redundant to say, but all correlations is showing me what? I mean, it's showing me, oh my God, 47 pages of it. This would be excessive output again, but it's way easier to read. Oh, except for when the words go like that. That's insanity. Probably if I decrease font size, that'll help with this. Or it won't help with it. Too long of words. Every variable in survey 11 pairwise with every other variable. It's doing all the correlations between them. Exactly, Kayla. But what variable would you like to analyze here? There's just say the number if you want. So just choose a number of a variable. Exactly set. It shows all the correlations between every single variable, and you can tell if it's positive, negative. What variable would you like to analyze right here? Just pick any variable. Like you can just say X this, like 26, 25, 24, whatever you want. Any variable. And if you notice if it skips a variable, it's because those variables were categorical. Like we can go confirm. We can just destroy the output right there. That 19 and 20, I think, were categorical. Computer and churchgoer, those were categorical. So it can't do those. It skips those because 19 and 20 are categorical. So you don't see 19 and 20 in the output because it can't do a correlation with a categorical variable. It skips those columns. So which one? X47. You know we can do this. Watch this. X47, because I think I have it attached. How much money are people carrying? This has to be in quotes. Don't forget that. Interest equals, and there we go. And guess what we get? Since we specified an interest, we only get this one, and we can change this. I don't know if it'll autocomplete with, darn it, doesn't autocomplete in the text box. How much people sleep? And now we've done this and we've analyzed. And this is what's cool. This is like data mining, right? Or data mining. It's just really quick and easy to get all the correlations. But there's an issue right here. This list is completely in Whatly right now what? Like, just look at the order of it. And does it really help us look through all this the way it is right now? If only we could do what to it? If only, and I'm going to make my code look nicer. If only we could go in and what our data set. If only we could just go in there and what this. We'll go look at 47.2 in a moment. If only we could just go in and what this data set. Man, if only we just had a way to what it. If only we just could take all this information right here and somehow something it. And if you're ever confused about the functions, we're about to give away the answer to this one too. If you're ever confused, you can always just do question mark all correlations, and it'll give you instructions on how to do it. You're right, Kale. Yep. And so here's the instructions behind me right here on the arguments. And so you can see kind of an example format right here with the different arguments with type. So we can specify which type of correlation we're doing. We can specify a variable interest. We can specify which way to sort it. We're going to use magnitude. You can also see examples of the function down below. But the help function right here using question mark is a really good way to just see how to use your functions. So we're just going to go type 3 letters. It auto completes. I don't think I copied magnitude. Now here's a big thing. Magnitude. I think I got it right. You'll know it's correct if it sorts it from the absolute value strongest to the absolute value weakest. So down here on the bottom, you should see things closest to 0. Up here at the top, you should see things closest to 1. How many of these correlations are statistically significant? Good question right here. Let's throw out 20 points if people can get it. How many of these correlations are statistically significant? I'm barely not blocking it. How many of these correlations right here are statistically significant? Are we popping? That might have been me. Is the audio popping, or I grabbed the mic a little bit and I was really close to it? Oh, pop up. Okay. Boy. I'm thinking of like Arrested Development when he's like, I want to share with you my pop secret. He's like, your pop secret? Like season 1 of Arrested Development. So good. I'm old. How many of these are statistically significant? You are correct, Kayla. 6 are statistically significant. And there's the 6 that are statistically significant because they all have p-values below 0.05. Now, a statistician is going to argue for a family-wise alpha via Bonferroni test. Statistician, you leave our stream. We don't care. We're going to find... Yeah, anyways, I'm not going to go into that. I've heard Community is good, and I think it's written by Justin Roy and Dan Harmon. Dan Harmon? I think Dan Harmon wrote on it, right? Or he was like lead writer. So I should check it out because I like Rick and Morty. So all that. And then I just added here a 1 through 5. So I'm only taking what? By adding this part to the end of it, because everything we've done here with all correlations, Dan Harmon, yep. I saw some community stuff and I was like, this actually looks kind of funny. I just never got into it. There we go. So you can, there's many ways to do this. You can save it into X. So what's up, Mubarak? So good to see you. We're talking about the all correlations right now. And you can save it into the X and manipulate the X, or you can just manipulate it as its own thing. So we're just talking about how to manipulate this object right here. You could do this. There's just 1,000 ways to code stuff. You could also save it into X and do the first 5 things of X. You could also take and put this in here. Oops. Put this in here and do this. All of these codes right now that I have on the screen are producing the same output. How many of these ways should you do? Actually, this produces nothing right now. All of these ways are doing the same output. How many of these ways should be in your assignment? I like to do things like this to make sure you're watching and make sure you look at your output when you complete it. How many of these ways should you do? And let's look at that X47. Is it not included in the function? I don't think there's a way to do only the top certain amount in the function. I could code it maybe. I might do that really quickly and then go back to 201. Here's the top 5 for the one you asked, Kayla. The top 5 things correlated with how much money someone's carrying is their height and their weight, which actually looks maybe it's a gender issue because height and weight are highly correlated with how much money you're carrying. And I mean, I've got like a side bag and stuff like that, so I might carry some change on me, but I think, so yep, only one of these ways exactly. And I could probably, I think I could code it pretty quickly. Let's go over here and so watch this, Kayla. We're going to change the function right here. Let me clear this. I bet, let's start the clock. Stat to 1 speedrun time. Let's see how quickly. Brian says he can do this in 3 minutes. Let's do a stat to 1 speedrun on this for fun. Here we go. So can Brian, in 3 minutes, recode the function to add an argument to it so that the function will return a certain amount of rows. So I'm going to try to code this in 3 minutes. I've got 3 minutes to do this, and let's see if I can do it. Here we go. Clock has started. Brian already hit a wrong button. Oh, we already got the function. Cool. Whoa, I hit a button and it did that. Okay, I actually don't even know what I hit. Can we copy this? We can, good. Okay, there's the all correlations function. So what we're gonna do is we're gonna store the function into, I just copied what was inside the function, and we're gonna go right here and we're gonna call this all correlations. We're gonna call it all correlations 2. And we're gonna store this function into all correlations 2. We need to look at the return of this, and it's returning the results, and here's the results it's returning. So let's put in here an additional argument, and here's all the arguments they're putting in. I'm just gonna space this out a little bit more. There's the type, there's the interest, and let's go here to return rows, and let's put NA for current. So we added an argument return rows that someone can put in, and then we're just gonna put, cool, we'll put in, I think return rows needs to be return rows. I think this will work. Might break if I don't put a value in. Return rows. Okay, good. And then let's go here and go to if, and then need to go if return rows, if it is not NA, if return rows is not NA, if return rows is not NA, then it'll run results, save into results of 1 through return rows, and needs to take this. Okay, I think that did it. That looks good. Let's go test the code. Let's go run our function, go here, and we've done that. We're going back to the code right here, and let's change this to all correlations 2. Did we do in 3 minutes? All correlations 2. We're going to take the same code we put inside of this one, and we're just going to take through this. There's the same code. This runs currently, and then let's go to return rows equals 5, and boom, we've done it. That was 2 minutes, 20 seconds. There we go. We'll hop back here to some tool 1. I'm on the wrong screen. But Kayla, we did it. We have now made our own custom function, which has a return rows argument. Does that make sense, Kayla, in 320 watching? Chapter 7 quiz, you got it. We're going to hop back to chapter 20, chapter 7, 27. 201 and 7, but that's just practicing some coding right there, changing a function, I guess augmenting technically. We grew the function, but yeah, so now we have an argument here, return rows, and we can choose how many rows to return with return rows. When we check here, it works. When it's not there. You bet. Let's do this right here. We got the data with the cat, the Valerie, and the cat. And so Ansley's got one. Let's do it. Let's hop back some 201. So great job, 320. You do not have the all correlations 2. Hey, if you want to edit your functions too, that's good practice. But I made this new argument, and I can return a certain amount of rows now. Let's do it. Let's hop back to that burger question. Thank you so much, 201, everyone. Let's do the burger question. I'm going to reopen the quiz. Let's go do the burger question. 201, we are pulling up the quiz. If you guys can't tell, I love coding. I just think it's fun. When you get something to work, it's like beating a video game. So 201, let's do this. Burger question. Where are you, burger question? Fat and calories. I think it's like question number 6. Watch this. No, it's not question 6. Here we go. Is this the question right here, Ansley? And then, oh wait, Bailey. I think Bailey asked first the standardized score one. So we're going to do the standardized test score one because I think Bailey asked that before. Thank you, Bailey, for reminding me. Bailey asked about the standardized score. Then we can go back to the burger one. We did do the burger one earlier, but I will redo it. So the standardized test score one we have not done today. So I'm going to go back here to the standardized test score one. Then we can definitely do the burger one. We did do it earlier in the video, but we can definitely redo it. If you're here, you get to ask the questions. And Bailey, thank you so much for waiting. Just a residual one. Awesome. So we'll do a little bit of a speed run through the start of this. Are you ready? We're not going to go to speed run screen, but let's practice this. Here we go. Okay. So we are predicting the math score from the verbal score on this question. We're predicting the math score from the verbal score. This person right here is our outlier on the graphic. They have, it looks like a 250, not that I've done this problem, 250 verbal and an 800 mathematics. We do have a general linear form through this. Q, straight enough. No outliers. It's an outlier. So there is a problem, and the plot does not look to thicken for our regression conditions. So there is an association, and it is positive. People with higher math scores tend to have higher verbal scores. We've got that correct. Are there any students who don't fit the trend? Yes, the 250 verbal and the 800 mathematics. The R is 0.673, which means we can say 45.3% of the variability. How are we getting that? We're taking this right here and we are squaring it. This is R squared right here. So 45.3%, that is the R squared, as in 45.3% of the variability in mathematics is explained by the variability in verbal. Remember your interpretations. Blank percent of the variation in Y is explained by the variation in X. So 45.3% of the variation in math score is explained by the variation in verbal score. Knowing someone's verbal score would help you understand what they made on math. There are outliers and there are people who break the trend. So we would know that we are choosing between these two. I didn't misclick a question, did I? So we know we're picking between either this one or this one. And this one says, this says they score above. Let's see, students who score one standard deviation above are expected to score, yep. So this is saying that they have a positive relationship. This one's saying a negative. This one has the right R squared, and this one says positive relationship, and we know there's a positive relationship. That narrows down the questions. Here we are with the equation. This is where we need the what. What do we need to solve this? If you're in my section, you'll be able to find this pretty instantaneously. We need the regression solver. Someone might be watching this video standalone. I want you to know what the regression solver is. In my sections, it's over here under modules. Please email me at bstevens@utk.edu. That is bstevens@utk.edu. If you can't find it or in another section, I will send you the regression solver. So what is the regression solver pro? The regression solver pro is something I made for problems we wouldn't be working out by hand. You can see it right here. We added a little bit more to it yesterday, but the version without the very bottom part is existing right now online via that link. So here's what we need. We need the correlation. We need the standard deviation of y, the standard deviation of x, the mean of x, and the mean of y, which is x bar and y bar. So let's go look at the problem. What is the correlation? It was given right here. They kind of put it in a weird spot. So the correlation is 0.673. There's the correlation. The y variable is we're predicting mathematics. So anytime we see mathematics right here, the mean of mathematics is 509.6. So the mean of mathematics is 509.6 because math is the y variable. And the standard deviation of mathematics is 168.9. So 168.9. The standard deviation of x is going to be for verbal. So verbal has a standard deviation of 183.6. Verbal is a standard deviation of, please tell me if I get something wrong, be like, Brian, 183.6. And the mean of verbal is 480. Thank you for making that a nice number. So now what you can see is it gives us the intercept, which we're just going to copy the intercept and round to 3 decimals. There we go, rounded to 3 decimals, and it gives us the slope. We copy the slope, we go back over here, round to 3 decimals, and there's the intercept and the slope. So remember, this is y hat equals b0 plus b1x. We have here the intercept interpretation, or excuse me, interpret the slope. There we go, that's what I said. For each 1 unit increase in somebody's verbal score, we would expect their mathematics score to increase by a certain amount. So it's going to predict an increase because of the positive slope. So for each 1 unit increase in verbal, which is the x variable, that's where verbal would be up here, we predict a certain amount of increase, B1 increase, which this is B1 right here for their math score. I wish they just gave you the context, but that would give the numbers away then. Predict the mathematics score for someone with a verbal score of 759. Now let's slow it down just here a little bit. How can we solve this? How can we solve? We're predicting for somebody with 759, so I need everyone's help for these last few. This is where the mistakes are usually made. Since we have the right equation, what are we going to do if we are predicting for someone who made a 759? What are we going to do if we're predicting for someone who made a 759 on their verbal score? We're going to predict their mathematics. So what are we going to do to make predictions right here? What are we going to do to make predictions right here? So we're going to predict somebody's mathematics score for someone who made a 759 verbal. Someone made a 759 verbal, which verbal is the x variable. So what are we going to do? We're predicting the mathematics score, which mathematics is this over here. This is predicted mathematics. That's what y hat means. It's predicted y variable. And we know they made a 759 verbal, which means that's their x. So what will we do right here? What will we do? We want to predict their mathematics score knowing that they made a 759 verbal. And that's what this equation does, is it makes predictions of what people would make mathematically. And you can see it here in the background. You can see the line. The line is making predictions. So these are all the predictions and these are all the actuals. Like these are Y's and these are Y hats. So what would we do right here to predict someone's mathematics score? Any ideas? So we know they made a 759 verbal. The question says they made a 759 verbal. And we want to predict their mathematics score. So they made a 7, that's the next question. They made a 759 verbal, and we have the equation, and we want to predict their mathematics score. So what would we do with the equation we have right here to predict the mathematics score? And if you know it, you're probably just like, oh yeah, do this. But this is where people get stuck on this one. Well, how would I make this prediction right here? So what would we do? I need help from someone. Who knows? No. I'll play a sad, happy music. No one knows. No. Are we stuck? No. No one knows the answer. Stretch. What do we do? We want to predict someone's mathematics score and we know they made a 759 verbal. I might check to see if chat is stuck. Yeah, Ansley, you got it. It's don't worry, people get stuck on this one. Like, someone's wondering, someone's watching this video and like, please, someone tell us how to do it. So you are right. Just plug 759 right there in, and we're gonna take 759. And the reason I say this, let me point out another big reason I point this out. And I think it takes both answers right here. So 620.33, round to the nearest whole number, 620. What you can do with the regression solver is you can go to the regression solver and just plug in 759 and it just gives you the answer. Yep, and so Bailey, you're probably saying yours right there. You just plug in the number. And so on the regression solver, the current one has this, and then the next one, like I've made a new version right here, which has you put in the actual to get the residual. So right here, we're gonna say, what would be the residual for her math score for this person? So I just want you to think about this real quick. Every year a student, okay. So if a student made a 1600, what did they make on math and verbal? This is the tough one right here that, like, as Ansley was pointing out, this is the tough one I think a lot of people get wrong. If someone made a 1600, what would you know? You would know in this instance, you would know their X is equal to 800 because they actually made 800 on verbal. You would know their Y is equal to 800 because they actually made 800. We do not currently know their Y hat, which is their predicted. And if we solve for Y hat, we can get the residual, which is residual equals actual minus the predicted. So the big thing to get right here is their Y hat. Does that make sense? So if we solve for someone's predicted value, we can get the residual, which is how far these numbers are away. Is this making, I think it was Bailey who's actually asked the question, is this making sense, Bailey, that we need to then solve for what the model predicts for them to get, and then we can find out how far away their actual is from their predicted? The perfect score is 800, so you plug in 800 and solve. And so pretty much, Ansley, you're right there. We're gonna use the same equation. Let's go look at that same equation again. And when I go to this equation, and you might be right. You might be right 100%. We'll double check. We can confirm. So we're going to go to this equation. And what are we going to put right here? We're going to plug in 800. So we are solving for this person's what now? We're solving for this person's what over here. Like, let me highlight it. Right now, we are solving for this person's what value. And you can see if we go look at this. We're solving for this person's because there's the Y over there. Tell me if you get it wrong by like a decimal or two, and I'll correct it. We're solving for their Y hat. We're solving for their predicted math score. So let's go ahead and solve their predicted math score. Tell me if you're wrong by like a decimal or two. I'll fix it. Maybe I'll be wrong by a decimal or two. Oh my gosh, look at that. I got it completely wrong. That was not on purpose. There we go. This is their predicted math score. And I think you just said it. I think you were perfectly right, because then we subtract from 800, and we have to make sure we do it in the right way, because they actually made an 800, so they would be where? And I think we're talking about this person basically. They actually made an 800, So they would have a positive or negative residual. So here's the person. This person's probably close to what we're talking about. No, they'd be over here. They'd be over here. Would their residual be positive or negative? Because they made an 800. Yeah, they'd be right. They'd be this person right here. That's the person right there. So they made an 800, and then they were predicted to make a 645. So you can kind of guesstimate the residual from this. Is their residual positive or negative? So you can see them. That's the person. They made an 800, 800. So with an 800, 800, do they have a positive or negative residual? That's the individual. That's the actual person. They made an 800 on the verbal. They made an 800 on the math. There they are right there. And is their residual positive or is it negative? So they have a positive. So we do the actual. They actually made an 800 minus the predicted. And just understanding that we're doing the actual minus predicted is key right here. We're saying they actually made an 800 and we subtract off the prediction made from this model over here, which was like 645. And here's the answer. Tell me if you get it wrong. I think you'll get it right. I think you got it. I could put the numbers in here too. Round to 3 decimals. That's 3 decimals. Check answers. What in the world did I do, everyone? I've done this problem so many times. Did I click wrong answers? I must have put my equations in wrong. I think I got my equations wrong. I did this problem yesterday. Oh my gosh. Correlation. I've done this problem so many times. Verbal is 480. Verbal's. Do you see it? Do you see it? Who sees it? Yeah, we can do the visualization next. Do you see it? Did everyone see the error I just made? So easy to make. One error. It's this quick. Math error. Now the good news is with the solver, we're just going to do it the quick way with the solver, is we can just take, tell me if, just tell me something. Like, especially if you do it like 3 times, on the 3rd time you make an error and like this, I'd be like, sure, whatever. That should do it. That means this is going to be wrong. So if you get that part wrong, you get the whole thing wrong. 759, this is why the solver's great. And then 800. Just automate everything. I might have just clicked the wrong answer up there. Round to the nearest whole number. And then this person made the perfect 800. Gotta be careful. I could make an error going so quickly. Okay. Round to 3 decimals. Oh, I did that too quickly. No, I didn't do it too quickly. We wouldn't. We asked more about residuals, Miranda. We would never have you use like the solver. We don't put those equations on the test. We ask more questions about like what would the residual be. So don't worry. We wouldn't ask you. Yeah, and Ansley, I definitely messed up. It was that 480, that 580 did it. If you punch the numbers in wrong, it destroys the whole question. So I made a huge error right there, putting in a number wrong, and that drastically changed everything. We just have to make our one mistake for the day, and yeah. And that's why I like to automate stuff, because we would never expect you to solve these equations that are being solved in the background right here. So if you look at the mathematics being done, oh, this is the calculation error. I don't know. I like doing stuff like that. You can look at the equations being solved right here. So I just put those right there. I thought it would make it so that no one would like make an error. So it just references those cells when you do the calculation here. Or this is where you input them, and then this is where you get the output from these. So all that good stuff. There won't be problems like this. There'll be ones where we kind of ask you about residuals and stuff, and positive, negative, and how they are interpreted, because no one is solving this stuff. No person who does statistics sits down and solves this. If you're doing regression, you're more likely to see output like this right here, and you would do an analysis of it. And these are the types of things people normally do, is they get a regression like this, and they get the line, and then you should know the output. It's way more important to know what this output is than to know how to solve the equation. Does that make sense, Miranda? And I think we're going to do... Bailey, if you want me to take a look, email me, Bailey, and I'll take a look. And then we'll talk about the visualization right up. Yeah, doing it with the regression solver makes it way easier. You can do it by hand if you want, but the regression solver just makes it... That's why I made it. I was just like, I don't want to solve these things by hand. I would make little math errors. Like, you just put a number, you take a number wrong, you put it in the calculator wrong. It's easier with the regression solver to see what you have written down, where if you're solving it by hand, you punch a number into the calculator and it's wrong, and then you have to look back and be like, where did I do it? If you have like a TI. Just so easy to make mistakes, but it's more important to understand this output. Let's just talk briefly about this, and then we'll talk about the visualization, which actually, you know what? This could be the visualization right here. Let's talk about this like it's the visualization, because this week's visualization is on regression. So this is a very good example to go across. So looking at this output right here, let's pretend this is the output for the visualization. So the first thing the visualization wants you to do, yeah, we'll do the fast food one next. You got it, Ansley. Let's do that next here. The first thing the visualization question wants you to do is it wants you to talk about the intercept, I believe. So you need some output like this. You do not need the analysis of variance section. This is an ANOVA. We don't do an ANOVA in this class, so you can close this one. Do not close any other things. Like you need the summary of fit, you need the parameter estimate. And let's talk about this right here. The first one is the intercept we are interpreting. So what is the intercept? We have to go way back here to the intercept interpretation. And here's our intercept interpretation. Our intercept interpretation is when x is equal to 0, we expect y to equal b0. So how would we use that intercept interpretation right here? How would we use the intercept interpretation? And first off, what is the intercept? Like a big question right now, like what is the intercept? You can just round it for the moment. I would write it up more in my report, but what is the intercept? Who knows what the intercept is in this equation? Like somewhere in this is the intercept. What is the intercept in this equation? So this is helping with the write-up right here. The intercept is going to be 230.39. Exactly, 230.39. That's the intercept value. Oh, no worries, Miranda. Let's throw some 20 points. So this is just practice. Don't worry. It shows you're watching the chat. It shows you're interacting. Like, don't worry about it. This is where we practice. This is where we can get things wrong. And it's like, it doesn't matter. Don't worry. It matters more on the test. Don't worry if you get something wrong on the test. I mean, try not to get things wrong. But the intercept. So what does this mean as we talk about fat and calories? So what would this, I want you to envision what they'd be marketing this burger as. How would they be marketing this burger when we say, when x is equal to 0, there's x. When x is equal to 0, we expect y to be equal to b0. There's b0 because y hat equals b0 plus b1x. You can also see what the intercept is down there. So how would they market this burger? And maybe I'll do the interpretation from there. Exactly. Thank you so much, Lauren, right there. Yep, from the line to best fit. So, yep, the linear fit right here. Lauren, we're throwing some 20 points also for Lauren. I even missed that question. Lauren helping out a whole lot right there. And also Ansley pointing out the output on the bottom also mentions it. But these are the questions I want you asking. Don't worry. We're all here to just learn. Thank you so much to everyone helping out. When fat is 0 grams, calories is expected. And so, Jesse, I'm just throwing out all these points because, Jesse, so good to see you in the chat. Like more unique viewers I see, I'm like, yes, more unique people watching. I love it. So we need to say expect because we're not saying it will be this. We're saying we expect it to be this. Like, here's what the model predicts. Not that it will be this, but the model predicts that it will be this. It's also a bit of an extrapolation. More on that in chapter 8 later today. It's an extrapolation because our model does not go down to that. Extrapolation is when you go outside the X bounds of your model. We'll talk about that later on. But we would say when a burger is fat-free, when it has 0 grams of fat, we would expect for the calories to be equal to 230.39. Does that make sense for interpreting the intercept? Because now we're going to do the slope. Let's go look at our slope interpretation. That's r squared. So here we go with the slope interpretation. So we have for each 1 unit increase in x, we expect y to increase or decrease by b1. So for each 1 unit increase in x, we expect y to increase or decrease by b1. So just think about what we're talking increasing right here. So for each something increase for a burger, for each blank of this in a burger. So you could say for each additional blank of this in a burger. What are we talking about is increasing in the burger by looking at x right here. So for each 1 unit increase in x, we expect y to increase or decrease, and that's going to be the sign of the coefficient right here, by b1, and that's going to be this right here. For each 1 unit gram increase in fat, we expect calories to, and then to increase, and then this right here is b1. So this value right here is b1, because this will be b0. It goes y hat equals b0 plus b1x, and so this is x. I'm going to destroy this output really briefly just to show something. This equation is written as y hat, predicted y value, is equal to the intercept, which is b0. We're just destroying the equation for the moment. plus B1 X. I think I can remake the equation. If I go here to linear fit another line, and if I close this down a little bit right here. So there we go. You can see the two forms. Yeah, exactly. Does this make sense to see this right here? The form of the equation is y hat. We are predicting calories is equal to B0. There's B0. B1 is the coefficient of the x variable, and the x variable is right here. So for each 1 unit increase in fat, we expect calories to increase by 10.6. Exactly. Perfect job right there, Lauren. And this is the practice we need, and this is how you'd be writing it up for the assignment. Like just putting in the numbers, as you can see. I think we were close to like right here. So you're just basically plugging in whatever x is, whatever y is. You're increasing or decreasing depending on the coefficient right here, and then whatever B1 is, which is the coefficient right here, and hopefully lining these up. Yeah, great job, everybody. This is the practice we need. And then statistical significance. Let's remove the red linear fit. This is like 15 years of using jump. I used jump before. No, I've been using jump for about 12 years. Yeah. Because when I came back in 2009, I started using jump. Oh, God. I'm getting old. Oh, yeah, let's take a look at this. This is my happy music. Okay. Cool. When we look at statistical significance, what are we always going to look at? When we look at statistical significance, what are we always going to look at? When you look at statistical significance, what are you always going to look at? You always have to look at this for statistical significance. What are you always going to look at for statistical significance? Because the biggest, everyone 320 should know this, 201 should know this. It's like statistical significance. I'm always going to say, look at this. Anytime you hear statistical significance, you're going to be like, oh, we need to look at this. You hear statistical significance, boom, p-value. And what do you look to see if the p-value is below 0.05? Now, are we concerned about the slope of the line or the intercept? If I told you, like, let's do an example here. You ready? If I told you, here is how studying impacts your grade, or here is how studying impacts your grade, which of these would give you confidence? None of those were the colors I wanted. So this is how much you study and your grade. So which of these lines, version 1 or version 2, would give you more confidence in studying? So which of these, version 1 or version 2, would give you more confidence in studying if I told you this is how studying impacts your grade? Version 2, exactly. And what do you notice about version 2? The slope is not equal to what? In version 2, nice job right there, people helping out. Lauren and Miranda, thank you so much. 20 points, both of you. B0 is when x is equal to 0 is the y-intercept. Exactly, Lauren, you're 100% right. And thank you, Lauren. I'm throwing 20 points again. You're answering questions that I'm missing as I set up some examples here, and I really appreciate that. You're 100% right. B0 is when x equals 0. It is the y-intercept. Like, so B0 in these graphics would be, that's B0 here. None of the colors are the colors I want. That's B0 here. So B0 is where it hits the y-intercept. That is B0. And so what do you notice about this? The intercept here looks to be 0, but the slope is not 0. The slope is this right here. Here's the slope of these lines. So this has a slope equal to 0. This one has an intercept equal to 0. But in terms of like saying which variable is B0, like price or mileage, I think we're predicting price, right, from the visualization. And then always look to see, look at the equation. So we'll look at that here in a second. So which thing would you want to say is not equal to 0? Which one are you concerned about, the intercept or the slope? Are you concerned about the intercept or the slope? We'll loop back to that one, Miranda, here in a second. Are you concerned about the intercept or the slope? Which of those is better if they're not equal to 0 for the relationship between y and x? The intercept or the slope? Which of those is the slope? Exactly. And so when we look at this output right here, we're going to look at the p-value of the slope. So when you look at this output right here, is this statistically significant, and what p-value would you quote? Is this statistically significant, and what p-value would you quote? Is this output right here statistically significant, and what p-value would you quote? Is it statistically significant, and what p-value would you quote? It is very statistically significant, and the p-value we would quote would be, it's super statistically significant. You got it. Yep, excellent work. And what p-value would you quote? Exactly, yep, this one right here, because this is the slope. This is the intercept, and the x variable right here is the slope, and that's the xy relationship on this one. It's also the significance of the model, which is something we'll talk about in 320. The p-value is the same right here because the significance of a singular variable model is the significance of the singular variable. And so this is the p-value. Does that make sense, Miranda? This p-value right here, because this is the one for the slope, this is the one for the intercept. We don't really care about the intercept being significant. Like in our examples we just drew up right here, so many Word documents, right? In the examples right here, this one has a significant intercept, but this doesn't have a significant relationship. This has a significant slope, but not a significant intercept. The intercept here could be 0. The slope here could be 0. So this one is where the slope is not significant, but the intercept is. That's not a good model. This one here is where the intercept is not significant, but the slope is. We care about the slope. The slope is the XY relationship. There's rare circumstances, like I see it used so rarely. Good question right there, Lauren. At least in our class, we won't. Some classes will test it, like nothing against Math 115. Math 115, great class. Bob Guess, I can't think of her name now. Not Dr. April Connor, but April Connor. Great teachers right there. They teach it more from the mathematical side. So for mathematical stuff, you could do it. We don't care too much if the intercept's not equal to 0 when we do a test on it. So that's what that would be testing right there. So we care more about the slope, which is the XY relationship. So let me just show the notes on this again, because the notes really kind of walk through what you should care about for this. And so if you're taking notes on this, when a p-value for the slope is below 0.05, it tells us that the relationship between x and y, which we see highlighted down below, is unlikely by random chance, i.e. there is a very strong evidence with a p-value of less than 0.0001. That's what we see in this output down here. That's the p-value we see for the slope, to suggest that the linear relationship between year and mileage of year and mileage is unlikely by random chance. Yes, it is statistically significant. Trying to make this as clear as possible. You really want to tell the reader and inform the reader if something is or is not statistically significant. Trying to choose a different color I haven't used lately. But you want to make sure the reader knows. I wouldn't highlight it like that. I'm just trying to draw your attention to it. But because of the p-value being less than 0.05, it is statistically significant. I think, Miranda, you had a question too about which variable to use. That might be more related to the assignment. Let's go look at the visualization assignment. And great questions to everybody. Really, really awesome office hours. Like, we've covered so much, and I really appreciate people being in here asking the questions, because then just we get to cover exactly what you want to know. And then we work the questions. So let's go look at the visualization assignment for regression. We're already halfway done. So right here, I've updated mine a little bit. If you're in my section, you should see mileage is the x variable. So when you write the equation, let's bring up a tiny little word pad right here. So if you were to write this equation out, I'll go right here. The equation will be written the following way. It would be predicted. It'd be predicted price is equal to, and then you will get some coefficient there. And I think it's a negative, but sure, we'll put a negative for now. Because I think the coefficient is negative. People can correct me. Yeah, because price is going to go down with mileage. So is the intercept when price is equal to 0 or when mileage is equal to 0? And so it is B0 plus B1x, but you will get a negative coefficient for this. So is the intercept when price is equal to 0 or when mileage is equal to 0 for a car? Is the intercept when price is equal to 0 or when mileage is equal to 0? And just think about how you would solve this if you solve for the y-intercept and what the y variable is here. We can expand this a little bit and show the general form of the equation. The general form without any variables in is y hat equals b0 plus b1x. Just could be positive or negative. And so this should help, when mileage, Because what you're going to do is you're going to plug this in, and if you plug in 0 for mileage, then this just becomes 0 right here. This would cancel out, and what would you get? You would just get the predicted price. So if you plug in 0 for mileage, that's for each gram increase in fat. Yeah, exactly, Miranda. I think you got it right there. Yep. No, that's fine. It's fine. Oh, no. Oh, my gosh. That's the second time the camera's done that. It's going to do it again here. That was on purpose. That's the second time the camera's done that, and that really scares me. Camera. No, don't do that. Don't do that. Second time the camera's done that. It did like a few days ago. Don't want the 4K camera to die. So for like each... so for... Well, we're not going to talk about mileage decreasing here. So it's going to be for each... What is the slope going to be for this? No. So yeah, we'll do the fast food one after this. You got it. We'll do the fast food one. Thank you, Ansley, for asking. No, it jumped out of my mind. So the slope is going to be... Well, no, you're on the right track. I don't want to 100% give the answer away. Camera, don't do that blinky thing again. So because the slope is related to the mileage variable, so we're talking about as mileage increases, what we expect to happen to price of a car. And also look at your model visually. So you should maybe see like, oh, when mileage is doing this, we would expect price to do this. Does that make sense? And then like read your sentence and see if it makes sense. Be like, does this make sense what I'm saying? I know that sounds crazy to say. Circuit when you increase mileage, we start. Yeah, exactly. Yeah. Yep, Lauren. You gotta learn. Yep. That's, or for each additional mile someone has on their car, something like that. For each additional mile that's on the car, we would expect yeah, exactly. As miles goes up, price goes down. That's like a basic. You could put that addendum on there. Make sure to use the coefficients and everything as we're doing in the interpretation. Just to briefly make mention again, make sure to use the coefficients right here. This is not the exact one because we're using year to predict mileage. But for each year newer a car is, we expect the mileage on a car to decrease by this. So you notice right here, we're using the coefficients and we've highlighted in this example. So I'll just pause on this screen and show that right there. Camera. I do have backup cameras. Well, just don't want to say to Haslam, hey, that really awesome camera. When you run it every day for hours, it eventually dies. I mean, that's the way technology works. You're welcome. No, excellent work. This is the practice we need. It's all about practice. I always state that these things are just, the more you practice it, I have people get to these exams and like, they're easy, but it's just because they practice them a lot. And I'm not saying like you got to be practicing every day, but you have to look at it before the exam, like not the night before. I mean, it doesn't hurt to study the night before, but if you study just the night before, it's like, wait, I don't understand. It doesn't make that much sense. So let's go ahead and take this stuff right here. We're going to copy this to the clipboard. This one is best done in Jump. I would use Jump for this, so everyone should have Jump. We're going to go to Jump. We're going to go to a new data table. To get to a new data table, go to File, New Data Table. File, New Data Table. Then you're going to go to Edit, Paste with Column Names. Do not click inside of here. If you see this, you did not paste with column names, please restart right now. Pause, restart. And once again, go to File, New Data Table. Do not click inside of it. Go to Edit, Paste with column names, and they'll be blue, not red. That's very, very key for this question. You can't have them red. If they are red, this question will not solve correctly. So this question is asking us, at first, explain why you cannot use the model to estimate the fat content of a burger with 600 calories. The way they wrote their equation to begin with is a model was created to estimate the number of calories. So they're estimating calories. So the model was created for predicting calories from fat, not the other way around. So they have that right there. I might need to order more wires because it could just be a wire. I mean, that'd be the version of the problem. If my camera has problems, that I'd prefer a wire going bad. Using an appropriate model, estimate the fat content of a burger with 600 calories. So now we're going to predict fat, and we do already have this in Jump. Check out just a minute ago where we put it in Jump. Is this the right data? 18, 31, 34, 34. We got it. So we are going to go here and go to Analyze, Fit Y by X. And using Fit Y by X, we are going to predict the fat. That's the one we want to understand, using calories to explain it. And here we are. We're going to hit the red arrow and go to Fit Line, which fits our regression line, and we're just going to minimize some of this output. This is the output we'd really care about right here. You can see the significance of the model. You can see the intercept of the model, which is negative. We're predicting fat, right? And let's go back. We are predicting fat. We put in the negative 3. There we go. And there we go. And the intercept, or the slope, excuse me, we just grabbed the intercept. And let's put this in right here. It should be correct. And now we need to predict for 600 calories. Probably the best thing to do is just plug 600 into the equation for calories. So 600. I'm like so afraid I'm going to type something in incorrectly. Did we do it? Did we beat my Pearson at its own game? Of course we did. Of course we did. One small error in typing will destroy these problems, though. But does that make more sense, Ansley, right there? This problem is best solved via jump. Makes it way easier to input the numbers and solve them and kind of go through everything. Were you able to get it, Ansley? Everything looked good. Problem solved, I hope. I hope. Fingers crossed. We'll hop here to space. Let's put on some music. Yes, Ansley, I love hearing that right there. We're going to play. I love this song. Chill music. Let's say hey to Mewbot. Mewbot, we never see Mewbot enough. Mewbot, how are you doing, Mewbot?
I am Mewbot.
You need to calm down, Mewbot. It's too loud.
I am Mewbot.
Okay, that's much better, Mewbot. We'll work on it, Mewbot. We're still reprogramming you. As my webcam, not webcam, but 4K camera flickers. As things just break. We will be back. All he can say is I am Mewbot. That's all.
I am Mewbot.
Mewbot, you're talking over me now. Just calm down. Calm down, Mewbot. We'll work on it, Mewbot. But we'll be back. Join in for class, everybody. We're going to have a huge Kahoot on Sunday night. Sunday night, 7 p.m. is the plan. Oh, quote, I am Mewbot. Let's put that in here. I like that right there, Lauren. Where's Mewbot's dashboard? Not that I can program him. He's a robot. Of course I can program him. There you are, Mewbot. So, quote. Where's my quotes at? Quote 58. Quote 58 is in the books. Make sure to join in for the Kahoot Sunday night. Mewbot's saying, let's go back. Awesome stuff right there. He should say it twice. Mewbot, talk to us.
I am Mewbot.
Awesome. With that, everybody, we're heading off. We'll be back. See everybody later. Bye for now, everyone. Bye.